sign.
I was not the only one who got stuck on that, though.
Really?
Yeah.
But it didn't take me 2 hours.
Who got confused on the double equal sign? Who got confused on double equal sign for comparing strings?
I mean, Emily told me about it before and I started
See?
using it,
Oh, wait, seriously? Oh,
but I would have.
oh, I'm such an idiot. I'm such an idiot.
All right, well, let's hold on.
I'm such a.
All right, everybody shut up.
No,
Actually, it should have, if you were just comparing it to slash quit as the,
But if you're using a method and you're passing in the slash.
oh, it came in as a different pointer. Yeah.
Yeah.
All right, well, so let's start off by reminding you at the high level what's going on. Am I recording? Am I sharing? And if you weren't reading Slack, we were talking about this in Slack, and it actually is an important concept. This isn't so originally it was advertised from I don't know, another one of those dumb Emily memes. Was it a meme or was it just text? I don't know. You know, that, oh, Java does it wrong because they don't let you use the double equal sign for comparing strings. So, you know, when we talk about the double equal sign operator, and this is really a programming language issue, so kind of maybe even a more of a 470 topic. But we talk about memory sum in here, so that's fine. We'll just deal with it. But the double equal sign, this is the primitive equivalence operator in most programming languages. So then you have to say, well, what are primitives? So our typical primitives are byte short, int long, char, yada, yada, yada. Strings are object types. Strings are not primitive types, but pointers, memory addresses, those are primitive types. So if I have the string, so if I say string s is equal to, actually, let's just put it in, I have like a program open, right? What am I using? Code, VS Code. Nailed it. Here, we'll just do it in our server real quick. Chat server. All right, now our chat server is no longer a server. All right, so if I have like a string s, and I say this guy is equal to hello. And I say string s2 is equal to hello. And I say string s3 is equal to world. And then I do something like system.out.println s equal s2. So s equal s2 will be true. And this is where you get frustrated. So when I run this, it's going to give you true. Let me show you that. There's my terminal. Is that it? And look at that stability. The client's been running for days. So good. All right. So there's my true. All right. So it's easy to get lulled into why that's a true. And this is why I argue that other languages are doing this wrong, because many other languages, Python included, make this work. Let me show you the false here real quick. Say string s4 is equal to a new string hello. S equal to s4 will be false, even though they both hold hello. It's a false. Why is it a false? Because the double equal sign here is the primitive comparison operator, primitive equivalence operator. It's saying, is the memory address of S the same memory address as the memory address of S4? Whenever I deal with string literals, the very first time I used the string literal hello here, it noticed that, oh, you haven't previously used this exact string. So we're going to go ahead and create some memory for it. We'll throw it into literal space for Java in the virtual machine. The second time when I said it here, it says, oh, we already have that literal stored in literal space. So we'll just set S2 equal to the same memory address. Okay. But when we said S4 here, I specifically asked for new memory. I built that string using the string constructor, who cares, but new memory was created. So what's stored in S4 is a different memory address than the memory address in S and S2. Because I didn't rely on this string literal. I instead said, I want this to be a new place. It's an extra special version of hello. So when I say S equal to S4, versus S equal S2, this guy is true, this guy is false. So unless you know what's going on, you might say, well, why isn't hello equal to hello? Because that's what you meant, right? In fact, 99.9% of the time, if you have two strings and you mean to compare those guys with the double equal sign, you probably mean, do these two guys hold the same characters? That's what you mean. So you could then make the argument. So let's just see, this will be true and then it'll be false. All right. So the complaint on Slack was, oh, Java sucks because the double equal sign doesn't work for comparing strings, and some other languages make it work for comparing strings. Now, from a convenience perspective, there's probably some truth to that. But from a consistency perspective, where we want to be able to trust that a language will behave a certain way all the time. If the double equal sign always compares primitive types, then we can always count on it. Because if we're in, so I think C# actually will let the double equal sign work, right? So, but let me give you another option here. So let's say I say random R is equal to new random. Random R2 is equal to new random. Now, first of all, the double equal sign in C# and all these other languages, it didn't matter how you created your strings, even if you use the new object type. If it notices it's a string, it'll compare those the contents of those strings. So let me import java.util.random here. All right, so strings are objects in Java, just like they are in any of these other languages. Now I have another kind of object. I just chose the random object, doesn't matter. If I do a system.out.println, R equal to R2, we'll get a false. Two separate memory addresses. And the thing is, in a language like C#, it would also be a false, because those are objects. You have two separate objects. You're comparing those objects to each other, and they're different memory addresses. They're going to be different. Why are strings this special case? Why should the double equal sign work for strings in some special way? Now, we could say from a human perspective, we could say, well, because they're strings. It's not an unreasonable thing, but they do need to make it, I think, more obvious, because you do have this thing when you're working with languages where you have this question mark, like how far, what does the double equal sign let me get away with? You know, where does it stop letting me do fair comparisons and things like that? And similarly, can you say, you know, is S less than S4? If I say something like that, maybe I'm talking about like which comes first in the alphabet, something like that. Okay, that doesn't work, and I can't think of one language that works in. There probably is one somewhere, but you know, so how do we compare strings alphabetically? I think actually it's called lexigraphically in Java. If we want to see, does one string come before another string? How do we do that? Well, just don't do that. That's what you do. There's a compare to method. So I can say like s dot compared to s2, and this is going to return a number. It'll return a 0 if they contain the same content. So you can also compare strings to each other using that. It'll return something less than 0 if this string comes before this string, and it'll return something greater than 0 if this string does not come before this string. So compare to can actually solve all those problems with a single one, including the equivalence. I would prefer a language to be consistent on how it treats pointers and not make some sort of special case. Now, having said that, we can really quickly, we can say, oh, Java, you're awesome, yada, yada, yada. But then we go up here and say, well, why are strings the only object in the entire Java language that I don't need to use the new keyword to call the constructor for? They've treated strings as special cases too, which then you can maybe leverage and say, well, why did you stop there? Make the double equal sign work for them. Yeah. So it's an interesting question to ask. But those are, when I talk about all programming languages are basically the same. Programming is the skill set, the language doesn't matter. And as we've gone through classes, we see something works a little bit different in one language versus another. These are those little tiny idiosyncrasies that you kind of have to like, oh, that's how that works. So whenever we have something weird that in C++ or something like that, that shouldn't be weird, but it's just the way it was put together, you stumble upon those. And once you've kind of started using that language for a couple of weeks or whatever, you kind of put those things, get those things under control. But largely the languages are the same. Yeah.
So the language treated string as a type, then should
If a string truly was a primitive type, but I don't, outside of old style C strings, which are just character arrays, I don't think string as primitive type makes sense. Because what's the definition of a primitive type? Going back all the way to 200. Built into the language only knows how to hold a value. That's all it can do is hold a value. The second you start introducing it has methods, it can do more than just hold a value. It's an object, which is fine. I mean, it's not better or worse than the other guy, but at that point it's an object. So I don't know how a minus, if you look at something like C, which treats original strings in C were char pointers. And what do we have? We have the string header file, which has a whole bunch of functions that operate on strings. Strings can't operate on themselves. You have like a function called like string length, strlen. You pass a char pointer to, and it tells you how long that string is. It walks it until it hits the \0 or something like that. So at that point, it is a primitive type, but any modern language, strings are objects because they can do things to them, to themselves. See, having said that, Python. Do strings specifically have functions? Do we operate on them? Because to get the length of a string in Python, we use the len function and we pass it the string. Then we treat strings like arrays in Python. They're a primitive type in Python. They don't have functions themselves. Okay. So that would be a good argument of why the double equal sign works then for strings and that. Well, it's still not a great argument because it still should compare the primitiveness of it, because the value of a string really at the under the hood, it's an array. So the string holds the base address of that array that you then have an offset from that you walk to get the contents of the string. So I'm not sure I fully can defend the double equal sign in Python, but at least the data type is a primitive type, which means you at the very least that whole s dot equals thing can't be a thing. You would have to have like a function called like string compare that you pass two strings to and it compared them. So in C, I think there's the strcmp that takes two char pointers as a parameter and returns that less than 0, 0, or greater than 0 value, but it externally operates on char pointers. So Python probably has something something similar, but the fact that Python has their double equal sign compares strings the contents of. So if I go back here right now, we have a true and then a false. S and S2 are the same because they have the same memory address. S and S4 are not the same because they have different memory addresses. So we get a false with this. So we get a true and then a false. But if I change that double equal sign to dot equals, dot equals, then I'll get a true and a true. Because now it's specifically comparing the contents of them. Similarly, I can write both of those guys using the compare to. You just want to add one more magic trick to your. Oh, it might be implemented in terms of compare to. Yeah. Maybe it comes down to which was written first, or were they written at the same time by different teams or something like that. That'll get us the same outcome. If two values compared to each other gives you a 0, they are the same contents. So there's all of our trues. So I'd make the argument that whenever you're comparing strings, you should be using a method to compare those strings to each other, because you probably mean contents of the string, not the pointers of the string. We likely don't care if they're in the same place of memory. All right, all that stuff makes sense. Questions about how strings, I don't know, work in Java and should work in other languages or whatever? The issue here would be like in a C#, you would have no way of saying, are these two strings stored in the same place in memory? Because they've overloaded the double equal sign to work for contents of, you now can't say, is this guy and this guy the same place in memory? We have no way of asking that in C#. In Java, we do. We use the double equal sign if we're talking about memory. We use the dot equals or compare to if we want to talk about contents. I guess I would say that's better, more flexible, whatever. All right, so let's throw in our /quit thing real quick, and then let's write Bittorrent. We're gonna write Bittorrent. Doesn't that sound fun? Why? All hard programs are made up of a bunch of easy parts. I mean, BitTorrent is effectively distributed file sharing, right? Where you're sharing bits at a time. So if all of us had an array of bits, or array of bytes, let's say, all of us had an array of bytes, and he wanted to have, get that file. If I sent him bytes 1, 2, and 3, you send him bytes 4, 5, and 6, so on and so forth. He can then load up his byte array with all the bytes coming from these different sources, and now he has the file. It's not that complicated when you say it like that, right? Well, right. But what keeps me from sending bucket 0, bucket 1, and bucket 2 to him with enough information that says this belongs to bucket 0, bucket 1, bucket 2? So arrange it there. Okay? And once you have your array completely filled, then you know, oh, I have data. Then you can actually export to a binary file or whatever, and now you have your document. You're going to see that it's impossible, but it's not as impossible as you think. What's making this problem impossible? Well, probably the student. Yeah, mostly you, I would think. Well, and him, obviously. It just takes him like, look, I expected it. I want you to. Well, but I have to, you have to have the disgusting code comment, but it has to be in order. So at some point when I get stuck on something, like, look, have you tried sucking less? You got to hit me with it.
I remember that.
All right, what am I doing? Oh, we're doing the quit thing. So we don't have to change our chat server at all. We just have to go over to the client and have, when we're reading in from our client, all the garbage, check to see, did you say /quit? So we'll go over to our client. Here's our check client.java. All right, so this is where we're reading in from the client right here. So we want to go ahead and get a let's call it line. Say line is equal to whatever the client read in. If line dot equals slash quit break. Otherwise display line. That should do it, right? You could do something like letting everybody else know that you were leaving. You could do something like that. Didn't we read name in somewhere? Or we just took that all with 9 line local input. Yeah, so this was our name, I think. Question? So we could do some, well, let's just run it first. And then maybe we want to announce to the rest of the world that, you know, Mike is leaving or Mike has left the room, something like that is what I'm saying. But quit should work as of right now. Let's go out here. We'll go ahead and get our server running. We'll get our client running. This guy, this is where it comes in as the question. So we'll say Mike. We'll say Dave. We say Mike and Dave have joined. Dave will type a couple of things. All right, and then all of a sudden, Mike will do a slash quit. Well, he's not doing stuff anymore, right? So he did, yeah, he ended. We didn't really give a very good indication that we ended. Why didn't we actually quit? Because we still have this thread listening. So when we break out of this, we probably want to actually exit the program. So this is going to get us out of main. I think we want to do like a system dot exit 0. That'll actually kill the process that this guy is working with. If we just do a return, I'm not sure if that would actually kill off this thread as well. I think it probably would, because when main ends, the thread would end too. Good.
Try to type in, yeah, type in that one.
Yeah, that's the reason why it didn't actually end, because this thread is still going.
Yeah.
Yeah, I mean, so that's why it didn't look like we actually quit, because even though we broke out of this loop, which then actually did let main end. So then that tells me main, this guy is separate from this running process. That process will not actually complete until this thread is done, but system exit should force it. I think this we'll see it actually die off. Here, let's just do a system.out.println. Ay, ay, ay. Goodbye, something like that. Let's kill off these guys. I don't actually have to restart the server, but I will. Let's do a slash quit there. It says goodbye. This client has actually ended now, along with all the threads that were part of it. A good programming practice would probably say we should have kept, and actually we do have access to the thread. So I'll show that in a second. But now if this guy does something else, it's not going to show up over here because that guy's done. Technically, we do have access to our thread here, LT. So before we say system.exit, we can say LT dot, is it exit? LT quit. I think that's a thread function. We can confirm it here. Java thread. Might be closed. Might be closed. It shows me all the methods that it destroy is deprecated. But it also inherits stuff. Stop is deprecated. Well, we won't have to. So this just inherits from object. We could say yield. Let's see what they say you should use for stuff. This method is inherently unsafe, stopping a thread. Causes it to unlock all the other monitors. What does interrupt the thread do? Yeah, I don't know if that's gonna. Yeah, I think we're relying on the operating system to clean up threads. We can interrupt it, but interrupting it might actually have a delay, especially since we have an infinite loop in there. I think we just let the operating system, because our process comes as a package deal. That's the reason to use threads. We kill off the top level process. All the other guys are dead. They no longer get CPU time. So I think we're okay the way we have this written. Yeah.
Okay, so you're not taking the out of your array list.
I'm actually not right now, which is probably not the smartest thing,
I was listening.
but because I'm not listening, it probably, yeah, probably. So what she's saying is I still have this print stream that's actually not a connected socket anymore. So if you tried to write to that, it actually probably just nothing happens. It probably throws an exception and then catches internally. So to cover that, we would go, did I write it in the it's in server? So we would then need to let server know. Well, core is where we collect it. So we have our broadcast method, we have our add client thread. Say public static synchronized void remove client thread print stream. We could take in the print stream. Should have just copied the thing above, but whatever. And we'll say core dot the client streams dot remove the print stream. And I'll just find the object in there with the same memory address. This goes right back to what we were talking about at the beginning of class. I'm now going to search for that memory address in my array list of memory addresses. But the only person who can call this is the thread that was spun up by the server who's talking to that client. So when the client sends a /quit to them, then we can go ahead and kill off that print stream. We can even actually kill the client from the server side if we wanted to, instead of the client dying on their own. So let's show that. So now we've given the ability to remove a client thread given a print stream. So we'll go in server. Here's the chat worker thread. So this is the dude who is working with the client forever. He reads in that message, if message dot equals /quit. Then we're going to go ahead and say core, remove print stream. The print stream is the client output. That's this guy up here. This is the same guy we added to the print stream. We're going to now remove him from the print stream down here if we received a /quit. And since we just did that, we don't want to broadcast that message. So we could do a break here, which will get us out of this infinite loop, which will make the run method of this thread die. We don't want to do a sys exit. I don't know if a system exit would actually break anything since we're doing it from a thread's point of view. But I just want to make sure that it doesn't act as if you're the parent. Say, system exit, kill off all of the connecting clients. We're done. So this, at the very least, will let this thread finish its run method. It's done what it's supposed to do, and we're gone. So that takes care of it on the server side, removing the print stream and yada, yada, yada. I did make this guy synchronize. So we make sure that removing the client thing doesn't have any impact on two people can't do that at once. So they can't change the contents of our client streams at the same time. Well, they can't change the contents on the removing side. We do, even though these guys are individually synchronized. I mentioned for this homework, you didn't need to take thread safety into consideration. We'll add that here in a second. But so technically it would be possible for something to be added to our array list and something to be removed from our array list at the same time. And since under the hood, array lists are not thread safe in and of themselves, that technically could cause a problem with the final state of your array list. Did the thing that was added not end up in there, or the thing that was removed not actually get removed? Or did both not happen? You know, it would be inconsistent on what the final outcome would be, because the array list doesn't protect itself. We'll come back to how to fix that here in a second. But at least for right now, our chat worker thread listens from the client. When the client sends a /quit, they go ahead and remove it. So we need to go back and make sure the client's actually broadcasting that /quit. So that's going to be over on the client side. We're checking for the /quit here. What we actually want to do is go ahead and spit it out to the client regardless. So they get, or spit it out to the server regardless, so they get the /quit. And then we'll check locally, hey, did I just send a /quit? If I did, I'm done. I mean, he's going to cut me off anyways, but I'm done. I'm not going to read anything else, and I'll say goodbye, whatever. That then does take away our opportunity to say such and such is left. We can do that at the server side. So on our worker thread here, as our dying wish, right before we remove it, we can broadcast the message. That our name has left the server. So we'll broadcast it one last time so everybody becomes aware of that. then we'll remove us from the client list, and then the thread dies. Otherwise, we're just broadcasting our normal message. All right, so we'll run our clients. Mike. There's Dave. Write some stuff. So we're going back and forth, then we'll do a /quit. We say goodbye here. This guy should now become aware that Dave has left the server. He can still talk, just at this point, he's talking to no one. Yeah, so that's, I think, does that solve the homework? Anything I'm missing there? All right, let me push those changes. And then let's talk about threads safifying. Is that a thing? Is that a word? Let's assume maybe. All right, so this is /quit support not thread safe. All right, so that should be up there now. All right, so let's go back and look at our core here. We already mentioned this a few minutes ago, but let's rehash. Those two methods there, I mentioned this is not thread safe. So typically when we're talking about thread safety, it's most often dealing with a collection of some type. So right now, when I'm modifying our client streams, remember client streams here is an array list, which inherently array lists are not thread safe. Okay, so since array lists are not thread safe, which is going to happen sometimes, you might have a resource that you're working with, and because of the way it was written or when it was written, it's just not written as being thread safe. That's not a problem, just knowledge we need to know, because then we might need to fix it. That's what we're going to look at doing here. So I have two separate situations here. This guy adds something to that array list. This guy removes something from that array list. Now, what I've done, though, is I have synchronized these guys, which guarantees that more than one thread can't try to add something at once. And this guy says more than one thread can't try to remove something at once. But you could have a thread try to add and a thread try to remove at the same time, which could then cause a problem. How would we fix it? Using only what we know so far. Go ahead. Semaphores. Okay, well, let's go down that. Tell me more.
So, one of the things is part of the problem is that two threads are trying to do different things.
Potentially, these two methods could both be called at the same time.
They use some of those to ensure that you put this in a critical zone, and then you want to go through it.
Okay, how do we do that? You do know. You're just stuck on the word semaphore.
Yeah.
What's a semaphore do? Okay, that's the details of it, but effectively a semaphore is a bouncer that says you can only do one person at a time for a binary semaphore. Only one person at a time can access this thing. Do we have anything that's on the screen right now that effectively says only one thing can call something at once? Go ahead. This guy, synchronized. That acts as a semaphore. It's a binary semaphore. Only one person can call this at once, and Java does the magic behind the scenes. Go ahead.
Is there a way you can have, like, synchronize the two arrays?
Well, indirectly, you would have to write a class that extends array lists. So you have, my special array list and then have all the methods be synchronized. You wouldn't need to do that in this case. But I think I even mentioned this solution last class, if I remember correctly. Go ahead.
You can put both of them in a method and then just-
Okay. You're gonna add to that?
Can you make
No, I just
four?
remember that one.
Can you make four synchronized?
You can't make a class synchronized, but even if you could, that might not be what you wanted. Because then you're saying, okay, nobody can use this class. Two things can't use this class at the same time, when there might be plenty of things that this guy does where that's just not a problem, right? So I could do something like public static synchronized void change the client streams. So I could write a method like this and maybe have it take in some parameters. So one of the things we need is we need a print stream. And then maybe we need a string. Do what with it? Something like that. So then maybe we ask the question, if do what with it dot equals add, then we'll call core dot add client print stream, passing it PS. Else core dot remove client print stream PS. Something like that. So when we call this guy, we'll call change the client streams. Come back over to the worker thread thingy. When this guy first is created, rather than call add client, we'll say core dot change the streams. I'm going to pass it the client output, and then I'm going to pass it the string add. That's what I want to do. Similarly, down here, when I want to remove it, core dot remove this dot client output, and then maybe type in remove. If I want to be careful with this guy, what's it complaining about? Back in core.
No, this one, you call it client.
Oh, thank you. Okay. Now, technically, if I say anything other than add right now, it'll remove it. So if I want to be, let's say, foolproof, we would just go into core and we would say else if you said remove, then we'll remove it. Otherwise, if you gave me any other babble, I'm just going to ignore what you did. Go ahead. Well, it sort of is a hack, but we still actually have a problem with it right now. I mean, this isn't cheating. We're just building our own. The critical section that we need here is around the whole thing of whether we're adding or removing. We need to protect full access, the read and the write, for that array list. And we're going to build it through, we could effectively call this our critical section. And we're synchronizing that critical section. All right. So now the question is, have we actually fixed the problem entirely yet? Why? What's still possible as we currently have it written? Go ahead. Yeah, these guys can still be called. So how do I fix that? Make these guys private. So now they can only be called if you're inside the core class, which we are up here. So we're allowed to do that. Do these guys still need to be synchronized? No, I mean, it's like overkill, right? We're synchronizing something that we're only going to call under a synchronized state, right? Because we're only calling it in these things here. Now we could say, well, do we still leave them synchronized in case somebody else calls them? We could do that. But do we know, do we have a plan for anybody else calling these? No. But are we actually protected from that? Could some other developer who's on our Git repository, could they go in and add some stuff to core? They would still be able to call this, right? So how do I fix it? Do I even need these methods? Can I just, if I'm adding something, can I just do the stuff we do when we add? And if I'm removing something, just do the stuff I do when I remove. And then just dump both these guys. So we don't give the option for other code segments to call those without at least them rewriting it or going through our change the client streams method. All right. From our perspective right now, nothing's going to really change in how this is running, but we've protected it a little bit. We've made it thread safe so far as we have control over who's allowed to make changes to our core.java. Start the server, start the client, start the client. All right, we'll type some stuff. All right, all that stuff is broadcasting. We'll type /quit. He's gone. Dave left the server. We'll type /quit. I'm gone. All right, so I think we have, generally speaking, a thread safe chat server. We can certainly sit here and add little stupid features to and things like that, but effectively we got what we want. All right, so questions about any of that? Because if I don't say update now, it's not gonna work. Oh, that's not the update notes. It's just build stunning presentations is the thing. I have a slide for set thread safe. Okay, yeah. So an important concept here is that word thread safe. That's something that's going to come up during your career at some point in time. And it's almost always going to be surrounding a, we'll just add to this, almost always will surround some sort of collection type. To the point that when you look at other collection types in Java, you'll find that many of them are thread safe. They have these mechanisms built into it. So as the programmer, you don't have to deal with it. That doesn't mean you shouldn't. Well, maybe it does mean you shouldn't deal with it if you know it's thread safe, but the programmer should still always be concerned about that thing. But we should know what thread safety means and the ramifications of it. Okay, how are we doing on our update? How does Bittorrent work? All right, everybody in here has heard of Bittorrent? and we're probably going to end up writing a little bit of a dumbed down version of it, but roughly, how does BitTorrent work? We have a network of a bunch of connected clients, right? So BitTorrent is what's called a peer-to-peer network. There has to be some centralized thing that connects the peers together. So it's still going to be at some level a client server type thing like we just made. But a bunch of connected clients either want, have, or partially have the contents of a file and participate in the sharing of the bytes of that file with other connected clients. All right. Now, one thing that we do have a problem with, and I'm sure none of you have ever done this, you never turn on your BitTorrent, download something, and as soon as you have it, you turn off BitTorrent. We don't want to share, right? Somebody else's job, right? Go ahead. Yeah. So, and BitTorrent innately is not there's nothing bad about the technology. In fact, it's pretty commonly used for like delivering software patches and things like that. But now you have so many connected devices that you even see them releasing updates kind of in batches. So not everybody gets the update at the same time, but the people who are getting the update are doing it through some sort of shared peer-to-peer type thing like this. Otherwise, if you're all, let's say you're updating Microsoft Windows, if you're all downloading the current update from Microsoft server, even if they have 30 servers regionally or something like that, you still are all sharing your download as Microsoft's upload, which might be a lot, but it's not infinite, right? We have probably more bandwidth to work with if I'm downloading part of the patch from him and part of it from her and so on and so forth. So really the technology is a pretty good technology for moving files around the internet to lots of people, large files, whatever, without and kind of maximizing your internet connection speed. Because you've probably seen before, you try to download something from a single source, you only get a certain speed. Yet if you're downloading, so using BitTorrent, you've maybe noticed that the more seeds that are available, the more people participating in the particular torrent you're working with, the closer you'll get to maxing your connection, because you now have the capability of downloading from more simultaneous sources, presuming that enough of them have the bytes that you need out there. But it's a way of kind of maximizing your internet connection speed. Because otherwise, if you have a 200 megabit per second internet connection speed, even though you have the capability of downloading at that speed, you're at the mercy of how much upload whoever you're downloading from can give you. What do they have left? You know, so if you're downloading from somebody who's on a 56K modem, I don't care what your download is, you're limited to their 33.6 upload. And that's only if they have really clean telephone lines and they're getting the full 33.6. So this is roughly how BitTorrent works. So we're going to have a server component to this. And we're going to have a client component to this. All right. The server is going to have kind of two modes. An incoming client can choose to start sharing a file. So at some point, there is someone out there who has the entire file. It had to start somewhere, right? Somebody has the entire file. They contact the server and say, hey, I have a file that I want to share with the world. All right. So I want to connect and I want to be part of that participation where I'm going to be sharing, you know, we could just pick a, you know, I don't know, some meme or something, a JPEG. It doesn't have to be a 2 GB file. We can just be dealing with like a 5 MB file. All right, so we can choose to start sharing a file, or we can ask to start receiving the contents of an existing file. So we might say the server maintains a collection of file names being shared along with a mechanism for, let's just start off with sharing that data. Client can either send or receive based on their request, and they will either upload the contents of their file. We're going to start off not doing this fully like BitTorrent. So initially this is going to be, hey, you want to share the JPEG with me? You connect to the server, you say, hey, I have JPEG xyz.jpg that I'm willing to share. I connect to it and say, oh, I see you have xyz.jpg. I want that. It then connects this so that you can feed me the bytes and I get it and save it locally on my computer. So we're not grabbing some of the bytes from you, some of the bytes from somebody else. We will. But right now, it's just you and I are sharing a file over the internet. We're kind of making our own FTP server or something like that. All right. So a couple of cool kids that will be involved here. Well, that's actually one word, but all right. So you're going to have something called a data input and a data output stream. These will be handy for sending things as bytes. We can read and for an input stream, we can write to a data output stream. All right, and we're working with bytes specifically. If you read in an int, you're reading in 32 bits, 4 bytes at a time. Okay, so let me start formulating the homework. Implement a file sharing service where a client can choose to be the sender or receiver, and it requires 2 connected clients to accomplish the task. Client 1 has a local file that they will send to the server through a data output stream. Actually, that they will send. I don't want to take you in a certain direction. You will send somehow through a data output stream. Client 2 has a desire to download that file given its name and will write it locally to its computer. Once transmission is done, both clients should have the file. Go ahead.
The idea that the flag one would send the server.
That exact question is why I removed that word from this. You can decide how you want to do it. There's a way you're going to do it that will be most compatible with our Bittorrent approach. But for this assignment, it doesn't matter how you want to. Ultimately, you're going to be using the exact same functions. It's just who's going to be doing the handoff. Is one client sending directly to another client, or is one client sending to the server who's then sending to the other client? Right. You probably should have a downloads folder then. You know, you're like, don't overwrite your same file. That would actually be, that might be time travel. You know, we just figured it out. What's this? Yeah. You know, download that JPEG or something. We're just doing this as proof of concept. Having one client send bytes and you working with a data input or data output stream for reading and writing bytes. We're not reading strings, we're reading and writing bytes. So we're working with smaller pieces of information. Submit a link to the GitHub repo and the self. All right, and we'll throw a hint on here. So I'll throw data input stream in here. We're going to have a data output stream. Those guys will be handy. Let's see anything else you're going to need. Let me just look at data input stream and output stream. One function you might need before, when we're doing like a next line and a read or a println, those typically have auto flush put in. You might have to, after you write something to a data output stream, you might need to flush it to make sure all the bits are, are flushed down the pipe. You can also, you see we have multiple ways of writing. So you can write a single int. And this is the low 8 bits of the argument. Okay, so when you write an int, you're actually only writing a byte at a time. Write byte. So that'll read in. This is saying you'll write the low 8 bits, which is still just a byte. Where this is writing, this is assuming that the int you're sending is a byte padded by zeros, but these guys will ultimately end up doing the same thing as it's written here. You can write a sequence of bytes. They'll come in as a string, which will be interesting, since a string in Java is a collection of 16-bit chars, because chars are in Java. I would encourage you to use write byte. I would deal with things as bytes. That'll be the you might have a situation where you might say, oh, I can send more at a time if I don't write it 1 byte at a time. We're effectively creating and networking what's called serial communication. We're going to send a byte, then we're going to send another byte, then we're going to send another byte, so on and so forth. So we're always dealing with bite-sized chunks. Then in the input stream, when we read, we can read a byte, which will read the byte that was just there. We can also read as much stuff as is currently there into a byte array. I would probably start off reading a byte at a time, and then just building up your file. For, let me look up file output stream. Yeah, with a file output stream directly, you can write some number of bytes. You can build a file output stream using the name of the file you want to write to, or you can build it using the file class that has a constructor for the path name. So you either create a file, then create a file output stream from that. So let me give you this for file output stream. That will be handy for this. And then you're also going to need file input stream. And these are all going to be pretty similar, like our print writer and stuff that we've been using. We're just now reading and writing from files. This would be a file input stream. Okay. Questions about that? So you're going to be using some new classes that you haven't used yet. You're still going to be using your normal socket. You're going to be using the input and output stream from that socket to, read and write bytes using the data input streams and the data output streams around those, rather than like print writers and scanners. We've been using print writers and scanners. Now you're going to use data input and data output streams. And then you're going to be doing file IO with file output stream and file input stream. You could probably use even a higher order file IO if you want to look into that, but this allows you to directly write bytes, so that way you're not turning it into something else. You're reading a byte, you're writing a byte. Why change it to a different type? All right, questions, comments, concerns, bribes? All right, I'll see everybody on Tuesday. Doesn't this one seem like it's